let's go through trig ratios. So this is going to be very, very important in the next, 2 years of your life, 3 years of your life. It's the basics of trig. It's called trigonometry. Trigonometry is the study of triangles. So we're going to be solving triangles without using the Pythagorean theorem, without using special right triangles. So this is like the other way to solve a triangle. So I can find all the side lengths, all the angle measures using trig ratios. So there's 3 of them that you need to know: sine, cosine, and tangent. So a lot of people say sin. This is sine, like a sine. This is cosine. Tangent, pretty much everybody can say correctly. Okay, so sine. We never deal with the right angle. So in our triangle, we have 3 sides. The hypotenuse stays the hypotenuse. And depending on which angle we're looking at, we have what's called the adjacent leg and the opposite leg. So the sine function is a certain leg over something. The sine function is the opposite leg divided by the hypotenuse. The opposite leg divided by the hypotenuse. So it's called a sine ratio. It's a fraction. It will help us solve an angle measure later or a side measure later. The cosine is the adjacent leg over the hypotenuse. So the cosine is the adjacent leg over the hypotenuse. The tangent of a right angle, not of a right angle, of an acute angle, is the opposite leg over the adjacent leg. Okay, so the way to remember these 3 ratios is at the very top, Sohcahtoa. Sohcahtoa. Sounds like a weird name, but this says that sine is the opposite over the hypotenuse. Cosine is the adjacent over the hypotenuse. Tan is the opposite over the adjacent. So if you remember Sohcahtoa, you can remember these 3. On your quiz on Wednesday, you will have to write this out before you start any other problems. And I will check it before you start any other problems. Because if you get these wrong, everything's going to be wrong on your paper. So it's always written at the top. It's on my board over there. So you have to remember Sohcahtoa. So how do we do this? So it depends on which angle we're looking at. So they'll always give you sine, cosine, and tan and one of the angles. Either A, B, or C. We usually never use the right angle, which is because sine of 90 is 1. It gets weird. So here we're looking from angle A. So angle A is where we're standing. So that's why BC is the opposite. Because if I drew an arrow across from my angle, that would be the opposite leg. Does that make sense? Opposite's across. The adjacent leg would be AC. Adjacent's right next to you. So opposite's across, adjacent's right next to you. The hypotenuse is always the hypotenuse. Remember, it's the longest side, the side across from the right angle. If I were to be looking from angle B, that adjacent and the opposite legs switch. Okay, so if I'm looking from angle B, AC is the opposite, this is the adjacent. So for example 1, I just want to write out, so sine is opposite over hypotenuse. So I'm just going to write out the letters of the legs. So that would be however big BC is over however big AB is. Cosine is the adjacent over the hypotenuse. So that's AC over AB. Tan is the opposite over the adjacent, which is BC over AC. So, when do we use this kind of stuff? I'm not going to have you write out the letters very often. So, the first step is going to say to write each trig ratio as a fraction and then as a decimal rounded to the nearest hundredth. From now on, you're going to get a lot of decimal answers. I always round to the hundredth, which is 2 decimal places, at least. The more you round, the more accurate your answer. So, here, if I'm starting off sine, I'm looking at from angle A. My first advice to you is to always label. Always, always, always label. I'm going to label in pencil because we're going to have to switch it up in a second. So when I walk around to help you, I'm always going to say to label. You want to label opposite, adjacent, and hypotenuse. So from angle A, which side is the opposite? 5, 12, or 13? 5. You can always draw a line. 5 is the opposite. I just put an O. Which side's the adjacent? 12 or 13? 12 is the adjacent. I just put an A. 13 always stays the hypotenuse, no matter what. So, if I want to find the trig ratio for the sine of A, that's the opposite over the hypotenuse. So that's 5/13. If I write that as a decimal, I get 0.38. Once you label these, this problem should be real easy. Because now the cosine is the adjacent over the hypotenuse. So what's that fraction going to be? 12 over 13. Which is 0.923. Let's do 3 of them. And then the tan is the opposite over the adjacent, which is what over what? 5 over 12, which is 0.417. Now, very rarely am I going to have you do both of these, but now let's look at the trig ratios looking from angle B. So if I look from angle B, the hypotenuse stays the hypotenuse. But from angle B, the opposite side is now 12. And the adjacent side is now 5. Does that make sense? Think about if you were standing at angle B. 12 is directly across from you. 5 is right next door to you. Don't get confused with the adjacent and the hypotenuse. Remember, the hypotenuse is always the hypotenuse. So for the sine of B, it's still opposite over hypotenuse, but what is it now? Which fraction? 12 over 13. 0.923. What's the cosine of B? What's the adjacent over the hypotenuse? 5/13. So do you see how these have changed? The sine of one is the cosine of the other. Cosine of A is the sine of B. What's going to happen with tan? What's opposite over adjacent now? 12 over 5. It becomes the reciprocal. It's okay to have a number bigger than 1. 2.4. Okay, it's okay to have a number bigger than 1. So when do we use this? When do we use this? Notice on this picture. Notice on this picture. Can I solve this problem using Pythagorean theorem that we already learned? Do you have 2 sides? No. Can you use special right triangles here? No. So we use trig when we can't do those 2 things. So I want to figure out how big this side is. So my first step to you is to always label. Because you're going to either use sine, cosine, or tan depending on which two sides I give you. So if this is your angle that you're looking at, it's not labeled A, B, or C, that's okay. But this is your angle. So which side is the opposite? 17 is going to be my opposite side. X is what side? X is the adjacent. My blank is the hypotenuse. So if I want to solve for X, I'm going to use the tan ratio because it's opposite over adjacent. Does that make sense? So I'm going to use tan. So here's how you set it up. It's kind of like just a proportion. We're going to say that tan of 31 degrees is equal to, now tan is always opposite over adjacent, 17 over x. 17 over x. So I have to solve for x. So here's what you do. You make a proportion. That's why we go over chapter 6 before we do chapter 7. Put the tan of 31 over 1. Now if I have two fractions, can I cross multiply? So this is going to be x times the tan of 31 degrees equals 17. The tan of 31 degrees is a number. In your calculator, again, you want to make sure you're in degree mode. Those of you who came in late, you want to hit mode and then make sure you're in degree. If you have a scientific calculator, it should already be in degree mode. So you hit mode, degree, and then hit second mode to get out of it. So the tan of 31 is a number. It's 0.6. So the ratio of every opposite over every adjacent is like 0.6. So think about if this was like 2x equals 17, what would we do if it was 2x equals 17? We would divide. We're going to do the same thing here. I'm going to divide both sides by the tan of 31. And then those cancel out. In my calculator, I can just do 17 divided by the tan of 31. And it, honestly, for this one, it doesn't matter if you close your parentheses or not. And you should get 28.29. So that's how long that side of that triangle is. This is the harder kind because we have to divide. So far, so good? This is kind of what we're going to be doing for like the next week. So you always set up your proportion, cross multiply. Okay, let's look at B. So B, again, I can't solve using Pythagorean theorem because I don't have two sides. It's not a special right triangle, so we got to use Sohcahtoa. So if this is your angle, 42 degrees, x is which side? The opposite, the adjacent, or the hypotenuse? X is the opposite if you drew a line. What's 52? 52 is the hypotenuse. Ooh, I can't talk. Do you see how it's the hypotenuse and not the adjacent? Remember, the adjacent's got to touch the right angle. So to solve for x, I have O and H. Opposite and hypotenuse. Am I going to use sine, cosine, or tan? I'm going to use sine. Does that make sense? Okay. So the sine of 42. So always put your degree with whatever trig ratio you're using. Sine is opposite over hypotenuse. So it'll be x over 52. This one's actually the easier one to do. Because watch what happens when I make my proportion. If I put the sine of 42 over 1, look what happens when I cross multiply. X is just 52 times the sine of 42. Just don't be careful. Don't like do 42 times 52 and then take the sine. That's like weird. In your calculator, I always try and put the normal number first. 52 sine of 42. Or you can do sine 42, close your parentheses, times 52. Okay, just don't do this. Sine 42 times 52 without closing your parentheses. Because then you'll get the wrong answer. See. So the side length here is 34.79. So like I said, a lot of your answers, before, if you got a decimal answer, you were confused. The majority of your answers now are going to be decimals. So always round to 2 decimal places. Okay, let's try C. So 29 is your angle. So always label your triangle first. 18 is which side? Adjacent. What about X? So am I going to use sine, cosine, or tan? I'm going to use cosine because it's the adjacent and the hypotenuse. So we would say cosine of 29 degrees equals, it's always the adjacent over the hypotenuse, 18 over X. As you get better at this, like by Wednesday, you'll be able to realize if the number's on the top, we're going to have to divide. If the number's on the bottom, you just multiply. But let's cross multiply and keep going for now. So we would get X times the cosine of 29 equals 18. I don't figure out the cosine of 29 until the very end. Because the problem is if you do it at the beginning, you round and then you get like the wrong answer. So here I have to divide by the cosine of 29. So in my calculator, 18 divided by the cosine of 29. So X is 20.58. Right now, today, we're only solving for one side. Eventually, Friday, Monday, Tuesday, you're going to find the other angle. You may find all sides. I may have you find not only this side, but this side. Okay, but right now we're just going to work on one. Questions so far? Okay, why do we use this stuff? Story problems. Trig has actually been used a lot in real life. If you want to know how far something is away from you without actually measuring it, you can use trig. So there's two things called the angle of elevation, angle of depression. Angle of elevation is like you're standing on the ground and you're looking up. Okay, how far up are you looking? So like if you're standing on the ground looking at an airplane or the top of a building, anything that's high up, that's an angle of elevation. Normally it's less than 90 degrees, right? Because I don't know how you go like that. It's kind of weird. Angle of depression is the opposite. You're standing at the top looking down. So it's the angle of looking downward. Again, pretty much always less than 90 degrees. It creates triangles. So we can figure out, like if I'm in the balloon, I can figure out how far away the money is from me by knowing the angle of depression and one thing. A lot of times you'll see it, we don't do an example, like an airplane. Because the airplane pretty much always knows its altitude. So we can figure out how far away the airplane is from like a runway using trig. Okay, rather than getting a tape measure out. So there's going to be lots of story problems. So you always want to draw a picture. I will not judge you on your pictures. Although some people do great pictures. I like to draw stick figures. Okay. You want to create a triangle in every picture. So for example 4, you're at the top of a roller coaster 100 feet above the ground. The angle of depression is 44 degrees. How far do you ride down the hill? So it's kind of weird if you want to draw the picture. So we're like at the top of the roller coaster looking down. Here we are. That's us on the roller coaster. We want to figure out how far down the hill we're going to have to go. The angle of depression This is usually our right angle. The angle of depression here is 44 degrees. So this angle from us down to the ground is 44 degrees. When you do an angle of depression problem, the triangle kind of flips. So just be careful. The top of the roller coaster is 100 feet above the ground. So I'm going to put the 100 feet right here. Because we're 100 feet above the ground. Does that make sense? Okay. We want to figure out how far down the hill we're going to ride. So our x is over here. So once you draw your picture, you got to label. Because you're either going to use sine, cosine, or tan. So this is my angle. 100 is which side? 100 is opposite. Because it's straight across, right? What's x? It's the hypotenuse. Because this is our right angle. So am I going to use sine, cosine, or tan to figure out how far down the hill I got to go? Remember Sohcahtoa. I got to use sine. Opposite hypotenuse. So I'm going to say the sine of 44 degrees is equal to 100 divided by x. Okay, the hardest part is figuring out, besides the picture, which trig ratio you're going to use. I will say for most story problems, it's tan or sine. Okay, so then you cross multiply. So x times the sine of 44 degrees is equal to 100. So x is 100 divided by the sine of 44. So I'm going to have to divide. So how far down the hill am I going to have to go? Oops. I don't know what I'm doing. So x is 143.96 feet. Make sure whenever you're doing story problems that you use units. Okay, I'm going to start getting picky about units. Make sense? Questions? Okay. A railroad crossing arm that is 20 feet long is stuck with an angle of elevation of 35 degrees. How high is the arm from the base? So we have a railroad arm crossing that's stuck. And this is 20 feet. Create like yourself a right triangle. Angle of elevation there is 35 degrees. So it's stuck. How high is the arm from the base? So this is the arm part, this is the base part. We're trying to figure out this guy here. How high is it? So then your next step is to always label. If this is my angle, x is which side? Opposite, adjacent, or hypotenuse? Opposite, because it's straight across. 20 is what side? The hypotenuse. So which trig function am I going to use again? I have to use sine again. So we're going to say the sine of 35 degrees is equal to x over 20. So you put the sine of 35 over 1, and we got to cross multiply. So x is just 20 times the sine of 35. Oops. So 11.47 feet. questions so far. We got one more. Okay, last one. You'll see a lot of kites. We're going to fly a lot of kites in this section. A kite is flying 150 meters in the air, and the string you are holding makes a 40-degree angle with the ground. What is the horizontal distance from you and the kite? How long is the kite string? Draw a picture. So here we are, down at the bottom. Here's our kite. Mine looks more like a diamond. Here's our, that's a bad right angle. We need to figure out the angle that it's making is 40 degrees. That goes right here. And it's flying 150 meters in the air. So it's 150 meters from the ground. So the 150 goes here. This is actually asking us two questions. Not only is it asking what's the horizontal distance from you to the kite, the horizontal distance from you to the kite would be, we'll put an X there. But it's also asking how long is the string. That would be here. So we'll make that Y. So we're actually solving for both other sides. We'll do more of this kind of stuff on Friday, where we solve for both sides. So you want to label. That's always your first step. So 40 degrees is my angle. 150 is what side? Opposite. X is the, and then Y is the hypotenuse. And when I say label, I just put O, A, and H every time. So if I want to solve for X, I have O and A. So what trig function I'm going to use? What's OA? I got to use tan. So we're going to say the tan of 40 degrees is equal to 150 over X. And then you cross multiply. So X times the tan of 40 degrees would equal 150. So I have to divide. Like I said, you'll get used to knowing which one to divide and which one to multiply. So 150 divided by the tan of 40. 178.76 meters. So that's the horizontal distance from me to the kite, like on the ground. Now let's figure out how long the string is. Now here's my thing. I know we know this side, 178. I could use cosine with this answer, but I don't ever like to use my answer in case I'm wrong. So I'm going to use the 150. So I'm going to use sine. I'm just going to use the 150 twice. Because if you use this answer, what happens if you're wrong? Then both your answers are wrong. So for this, the length of the string, I'm going to say sine of 40 degrees is equal to 150 over X. You can put this over 1 and cross multiply. X times the sine of 40 degrees is equal to 150 degrees. So you're going to have to divide. So X is 233.36 meters. Question.